Antarctica, an icebound continent, endless white, bone-dry cold, and silence. But beneath the ice and in the pages of deep time, this frozen world keeps a secret. It was once green. Moss and trees, broadleaf leaves, and forests that grew near the South Pole. Tonight we follow the footprints of those ancient woods and watch how a warming planet is nudging life back across an icy frontier. Antarctica today is a continent defined by ice, a seemingly endless expanse of white that covers nearly 98% of its surface. It's the coldest, driest, and highest continent on Earth, a place of extreme conditions where life clings to the very margins. Yet, locked within its stone, buried beneath the ice, is a secret history that tells a radically different story. A story of a green and vibrant past. Across the continent, from the towering Transantarctic mountains to the windswept coastal cliffs, scientists have made a staggering discovery. They have unearthed the ghosts of ancient forests, fossilized tree trunks, perfectly preserved roots, and the delicate impressions of leaves are etched into the rock, irrefutable evidence that this polar desert was once covered in dense woodland. These remarkable remains paint a picture of a time when Earth's climate was far warmer, and Antarctica itself was in a completely different position on the globe. It was a key part of the supercontinent Gondwana, located at latitudes that could support sprawling, temperate ecosystems. In some of the most astonishing finds, researchers have located entire fossil forests. Tree stumps, some several feet in diameter, stand upright, exactly as they grew hundreds of millions of years ago. Their root systems are still anchored in the fossilized soil. This isn't just scattered debris, it's a complete ecosystem, petrified in place. These ancient trees, dating back to the Permian period, are early conifers, ancestors to the pines and firs we know today. They are a silent testament to a world lost to time, preserved in what are now the Transantarctic mountains. But the story doesn't end there. Other studies, analyzing younger rock layers, point to more recent chapters in Antarctica's green history. During the Cretaceous and early Cenozoic periods, roughly 90 to 50 million years ago, global temperatures soared. Even at high polar latitudes, the climate was mild and humid enough to support lush, near-polar rainforests, teeming with ferns, conifers, and flowering plants, a world away from the ice we see today.
What we see in the rock is extraordinary. Tree stumps preserved upright, roots in place. You can literally put your hand on the bark of a 280 million-year-old tree. That's a forest preserved in stone. It tells us that the climate and the continent's position were completely different. It's a direct window into a past world.
This timeline, written in layers of stone, chronicles multiple epochs of warmth. From the Permian forests of Gondwana to the Cretaceous rainforests thriving near the pole, Antarctica's fossil record is a crucial reminder that our planet's climate is not static. It has undergone dramatic transformations, turning vibrant worlds of green into the icy landscapes we know today. These were not tropical rainforests like the Amazon. Polar forests were a mix of conifers, ferns, and broadleaf plants adapted to long seasons of light and dark, sometimes cooled, sometimes warm, with high precipitation in some intervals. Fossil pollen and plant remains link these ancient Antarctic floras to lineages that today still survive in places like Tasmania, New Zealand, and southern South America. On rock surfaces, Earth changed. Plate movements, ocean currents, and atmospheric shifts cooled Antarctica. Ice advanced, forests receded, and by the late Cenozoic, the continent became the great ice sheet we know today. Paleoclimate reconstructions and fossil records show a long cooling trend that gradually removed forest ecosystems from Antarctica. Though the vast, ancient forests vanished beneath the ice, life did not surrender. It found refuge in the continent's harshest corners, clinging on with extraordinary tenacity. Today, Antarctica's vegetation is a testament to survival, a humble yet remarkable collection of the planet's toughest organisms. These are not towering trees, but miniature ecosystems, sprawling carpets of moss, resilient liverworts, and colourful crusts of lichen that paint the bare rock. They form a living patchwork, a fragile mosaic of green, orange, and black against the stark white landscape. Each patch represents a victory against the extreme cold, desiccating winds, and months of darkness, surviving in microclimates where the temperature inches just above freezing for a few short weeks a year. In this world dominated by cryptogams, only 2 native flowering plants have managed to secure a foothold. On the relatively balmy Antarctic Peninsula and its surrounding islands, you can find Antarctic hairgrass, Deschampsia antarctica, and the tiny cushion-forming Antarctic pearlwort, Colobanthus quitensis. These vascular plants are restricted to the scant 1% of the continent that is ice-free, primarily coastal zones where seabirds help enrich the thin soil. Their very existence here is a biological marvel, a fragile link to the continent's greener past, demonstrating life's incredible ability to adapt and endure in the most unforgiving places on Earth. And now, this fragile green frontier is expanding. Recent satellite studies, analyzing decades of imagery, have revealed a startling trend. Plant cover, mostly ancient moss beds that have been growing for centuries, has increased dramatically in specific locations. Along the northern Antarctic Peninsula, some moss banks have shown a 4- to 5-fold increase in growth rates in just the last 50 years. This acceleration is a direct and visible consequence of regional warming, which is creating longer, warmer, and wetter growing seasons. The ice is retreating, exposing new land for colonization.
We're watching the continent green at its edges, in real time. It's a slow and limited process, confined to these coastal fringes. But the trend is clear. More plant cover is appearing where conditions have warmed and become wetter. This isn't a return to the prehistoric forests, but it's a profound ecological shift. As these pioneer communities expand, they change the soil, retain more moisture, and create habitats for other organisms. We are witnessing the very first stages of a new Antarctic ecosystem being born from the thaw. It's a powerful indicator of how sensitive this polar world is to even minor changes in climate.
Antarctica's living tapestry is dominated by the sea. Penguins, flying seabirds, seals on the ice, and majestic whales offshore. These are the continent's large animals. Unlike ancient times, modern Antarctica has virtually no native terrestrial reptiles or amphibians.
Most Antarctic life is marine. When we study the ocean, we're really studying the lifeblood of the entire continent.
The astonishing record of a green Antarctica isn't just a historical curiosity, it's a profound warning and a critical lesson for our time. It demonstrates with startling clarity that when key climate drivers like atmospheric carbon dioxide and ocean heat change radically, entire ecosystems are forced to respond, often on a planetary scale. The fossil record acts as a natural experiment, showing us precisely how life reorganizes itself under these new conditions. During the Cretaceous, when those forests thrived, CO2 levels were significantly higher than today, trapping heat and creating a world without polar ice caps. This ancient data confirms the fundamental physics. More CO2 means a warmer planet. What we are witnessing now, with our own rapid warming, is the beginning of that same process of reorganization, as life at the fragile margins of the continent begins to shift and adapt to a changing world.
It's crucial to understand that the past is not a direct playbook for the future. The continents were in different positions and the rate of change was much slower. However, it provides an invaluable and powerful data point. It gives us a real-world case study for the sheer scale of transformation that is possible when climate thresholds are crossed. It proves that the Earth system is capable of dramatic shifts. This knowledge underscores the gravity of our current situation. The unprecedented speed of modern, human-driven warming means we are pushing the system far faster than what we see in the geological record. This has the potential to not just alter, but to fundamentally and perhaps irreversibly reshape polar ecosystems within a human lifetime, with consequences that will ripple across the globe.
Antarctica's story is a story of transformation, from forested polar valleys to an ice dominion, and now a fragile greening fringe. The lost rainforest is both a fossilized memory and a possible hint of what a different Antarctic could look like if climate patterns shift dramatically. The question is not whether change is possible. The question is, what path will we choose?